Welcome to Chibuzor Mathphysics. In today's video, we shall be dealing on this calculation on quantum mechanics or quantum physics. Before we dive into the calculation proper, it will be good for us to take a step backward to introduce Bohr's model. In atomic physics, when we talk about Bohr's model, or what we call the Rutherford-Bohr's model, this model actually is presented by Niels Bohr and Ernest Rutherford in 1913, and it talks about a system consisting of a small dense nucleus surrounded by orbiting electron. So it is all about a system of a small dense nucleus. So the Bohr's model postulates is a kind of assumption that electrons orbit the nucleus at fixed energy levels. So it is this energy level that we are to calculate, and you can see from the equation we are to calculate the energy of both the initial state. The initial state of this energy is equal to 5, and the final state is equal to 2 of that electron. Using the energy equation of hydrogen, will be En, that is the energy number of this hydrogen, is equal to negative 13.3 electron volt, that is eV, by n squared. So once the energies are known, we can go ahead to calculate the difference in energy, convert it to joules, and then find the wavelength. Then we can the wavelength can then be found using the equation lambda is equal to hc, where h and c is constant, and then we divide it with the magnitude of that energy. Stay tuned and enjoy this calculation on quantum physics. So now let us have our solution. The first thing we are going to do is to calculate the energy of the initial and the final state. So the first step will be step 1. We have to calculate To do this using our formula as indicated in the equation, we know that En must be equal to negative 13.6 electrovolts. So this implies that we are using the equation En is equals to negative 13.6 electron volts into N squared. So we start with the initial state. The initial state is equals to 5. So N is equal to 5, meaning that we have E5, we have En, so it is E5. This will be equal to negative 13.6 EV into 1 by 5 squared, because we have N squared. We have N squared, so it is into that. If you plug this into your calculator, you will simply get negative 0.544 electron volt EV. So this will be the initial state. The final state we have E2. Following the same process, we will have negative 13.6 EV into 1 by 2 squared. This will give us negative 3.40 E volt. So this will be the first step. This is the first step. Let us proceed now to the second step. The second step is that we are going to use the energies from step 1 and 2 to calculate the magnitude of the change in energy and then convert the result to joules. We have to convert the result to joules. So to do this, we have to first of all use the energies from step 1 to 2 to calculate the magnitude of this. So this implies that the change in energy will be equal to, of course we are taking the magnitude of this, so it will be equals to the energy, the final energy, which was 2 calculated, minus that of the initial energy, that is E5. This implies that the final energy was negative 3.40 electron volt. So it is negative 3.40. We have negative 3.40 electron volt minus, because here we also have negative 0.544. So it is negative 0.544 electron volt. But we are taking the magnitude of this. So since we are taking the magnitude, so we ignore the negative sign. So we simply take this value minus this value. Since it is a magnitude, we have to ignore the negative side. So if we take the magnitude, we'll end up with 2.86 electron volt. 2.86 electron volt. But remember, we have to convert this into joules, and we know that 1 electron volt is equal to 1.60 times 10 negative 19 joules. To convert this to joules, 1 electron volt is equal to 1.60 times 10 negative 19 joules. So if this is equal to this, how can we convert 2.86 into joules. This will be very simple. We simply need to take 2.86 electron volt. We multiply this by 1.60 times 10 negative 19. Negative 19. Then we divide this by 1 electron volt. So this is what we are doing. By so doing, electron volt will cancel with electron volt. 2.86 multiplied by 1.60 times 10 negative 19 will give us 4.58 times 10 negative 19 joules. So now we have converted this electron volt into joules. The last step, remember the question says after we have converted this into joules, we need to find the wavelength can then be found using the equation. So we are going to use the equation lambda is equals to hc into the magnitude change in energy. So let us use this formula now to find our wavelength. So the final step here will be to find the wavelength. We know that wavelength is given by lambda, which is equal to hc, lambda hc divided by the magnitude of that energy. Hc, c is simply the speed of light, and all these are constant. So h is given by 6.63 times 10 negative 34, which is a constant, negative 34 joules. Of course, into seconds we put that, multiplied by c, which is the speed of light, and that is given by 3.8. It is simply 3 times 10 power 8 meter per second. But we can cancel this both, so that we divide it by the change in energy. Of course, the magnitude of energy as calculated, we got 4.58 times 10 negative 19. We just need to plug into that. So it is 4.34 times 10 negative 19 joules. So our final solution will be, plug this into your calculator, you will get 4.34 times 10 negative 7 meters, because we know joules, this is joules, so this will also go with this. So this will be our solution, or you can reduce this to 434 nanometers. So this is our solution to this question, and this is how we deal with Bohr's model of the hydrogen atom. When you are asked to calculate a kind of the energy state, you are given the initial and the final state. Stay tuned and enjoy more calculation. This is Chibuzor Mathphysics, and don't forget to hit the subscribe button so that you'll be notified in our subsequent videos on nuclear physics, quantum mechanics, and mathematics.